Megan! I need help! What's an earthquake?
Well, I'm glad you asked, Becca, because an earthquake is ground shaking caused by movement of the earth along fractures called faults. And here, I made you this poster of a fault. Thanks! Okay, so first we're going to talk about the different parts along the fault and the things that make an earthquake happen. So first, the location where slippage begins at depth is called the hypocenter, also known as the focus. Now, the point directly above the hypocenter or focus on the Earth's surface is called the epicenter. Alright, so do you know what the study of earthquakes is called?
No.
It's actually called seismology. Seismology is the study of earthquake waves. Easy enough. The instrument used to measure these waves is called a seismograph. Now, how these seismographs work is they're actually planted down into the bedrock, and then there's just a suspended weight, and it's held still, but it draws the record onto a rotating drum. Now, the weight is stationary, and the rotating drum actually detects the ground motion. And these records from a seismograph, they're actually called seismograms. Alright, Becca, so when we're talking about seismic waves, we're going to talk about three different kinds of waves. The first one is called a primary wave, or sometimes they refer to them as P waves. So a P wave is basically the first wave to occur in seismic activity. The second wave to come has the name secondary or S waves. Now these are, like I said, the second waves to occur in seismic activity. Then come the surface waves. There are two different types of surface waves, which we'll talk about in just a minute. But first I'm going to show you how this works. So usually we have the primary waves first. We detect these primary waves. And then there's this amount of time between the primary waves and the secondary waves. And then we have the surface waves. This is what a seismogram would look like if you were looking at it, of a real earthquake. Something similar. This is the first kind of surface wave. Now you notice the wave direction is going this way, to the right. Now this kind of wave motion goes like, waves in an ocean, which actually underground the motion is going this direction, in a circular direction, which causes these waves on the surface of the earth. And you can see the trees are tilting, the houses are tilting, so it's moving like this. The second kind of wave is known as a side-to-side wave. Now notice that the wave direction is going this direction again. Now the wave motion is more going side to side, like this. Notice this section is going this way, this section is going this way, and so on. So you see that the road that had once been straight across is now broken and being pulled in different directions because the wave motion is going in a side-to-side pattern.
Am I missing something? Because there is not a difference between intensity and magnitude.
There are not the same things, but lucky for you, I made you a poster. Oh, yay. Now, intensity is in the pink. Magnitude is in the blue. Here's the difference. They both are how we determine the strength of an earthquake. But intensity of an earthquake is the measure of the amount of ground shaking based on how much property damage was done. So it's more for like historical purposes. Now, intensity is generally measured with the modified Mercalli scale, and magnitude is not. Because magnitude of an earthquake is a more quantitative measure based on data from seismic records of the amount of energy released in the earthquake. Magnitude is usually measured using the Richter scale, and this scale is calculated by measuring the amplitude of the biggest. Okay, now these represent two pieces of land. Now they come together like this. Now, in a fault, we have the foot wall, which is the one that is slanted this way, and we have a hanging wall, which is slanted this way. And they come together just like this. Okay, so for a normal fault, the foot wall moves up and the hanging wall moves downward. So they move just like this. See, this foot wall is moving up and the hanging wall is moving downward. In a reverse fault, the foot wall moves downward and the hanging wall moves upward. So it would move like this. The hanging wall moves upward, the foot wall moves downward. In a thrust fault, although it's hard to show with these two because they are styrofoam with this model, the thrust fault is when the hanging wall would go up over the fault or over the foot wall, but this would form over the land. So it would almost form like this, only this would maintain down here. And the very last fault that we're going to discuss in this video is a strike-slip fault. And this is when the hanging wall and the foot wall move side to side. Like cars on a highway. They don't move up or down, they just move past one another.